Example 3 states that if the equation 2x squared plus 5x minus the quantity 3k plus 4 equals 0, if that has two real and distinct roots, find the range of values of the constant k. Lots of stuff going on here. It's quite interesting. So we know that there are two real and distinct roots here. So two real, and distinct roots means that we've got b squared minus 4ac is going to be greater than 0. Right? Because we know that if our discriminant is a positive number, then we know that that we have two real and distinct roots, and it works conversely the same way. So we need to figure out what b and a and c all are before we move on. So if we look at our equation here, we've got 2x squared, we've got plus 5x, and we've got minus 3k plus 4, and that equals 0. So let's start identifying some stuff. So a represents the number of x squareds. If we look through here, a is the number of x squareds. Well, there's 2 of those. B is the number of x's. Well, there's 5 of those. Now, C is everything that's left over, right? Anything that doesn't have an x attached to it. This is the entirety of C. Now, it's including the parentheses. Now, if you want to, you can go ahead and distribute that negative, but not necessary. We can leave it as it is. Now, what we can do is plug this in with our discriminant formula and see what lies beneath. So, we start off with b squared. So, b squared is going to be 5 squared. We subtract 4 times a, which is 2, and then we're multiplying that by this negative 3k plus 4 kind of job. And that is greater than 0. So we've got a little bit of simplifying to do, but ultimately we've got what we need. So we're just trying to find these ranges of values. So as long as everything's plugged in right. So 5 squared is 25. And we also we've got negative 8 times negative 3k plus 4. There's many things you could do here to simplify. I'm going to go ahead and see that I've got a negative times a negative. That's going to make this positive. So that's kind of nice. So I'm going to get 25. And then so negative 8 times that. So I'm going to have, it becomes a positive 8 times 3k plus 4. Again, multiple ways you can go about that. Just be careful where you're not dropping negatives. So we get 25 plus 8 times 3k is 24k. And 8 times 4 is 32. That's greater than 0. Now, at this point, we want to try to get k by itself, and we want to try to get everything else on another side. Right, so we're going to try to solve for k, because this isn't a quadratic equation. This is more of a linear inequality. So we're going to leave the 24k over here. I moved the 25 and the 32 over, so it's negative 25 and negative 32, which makes negative 57. And so we end up with k being greater than negative 57 divided by 24. Now, that seems absolutely nuts. Right? What kind of number is that? Well, it's the number that if k is any bigger than that, we are going to end up with two real and distinct roots. If k happens to be that number, we're going to have equal roots. But if it's less than this number at all, we don't get real roots at all. So it's very interesting. So be aware that everything evolves back to our discriminant. Everything comes back to that. We just want to use correct mechanics when identifying parts of the quadratic equations so that we can build our discriminant and we can make a true statement that will work.